Okay, hello everybody. So the convex hull of a list of points is a set of all convex combinations of those points. Okay, so A, what is a convex combination? Give the formulas. A convex combination of, this is important to say, of what? Of vectors or points P1 through Pk, some number of them, is a linear combination. I mean, sort of mid-sentence, I give a formula, C1 P1 plus C2 P2 plus ... plus CK PK. I had K points. I could also write this as the CI PI and a sum of K terms if you want, where each CI is a non-negative real number, is a real number like 2 or pi. It's not a vector. CI is not a vector. And each PI is a vector, So this is saying that each of the P's is a vector. This is saying each of the C's is a real number that is non-negative. And the sum of the C's, namely I'm adding up real numbers, is equal to 1. Okay, like when you're taking the average, it's equal to 1. When you're taking probabilities, they have to sum to 1. It's sort of this idea. It's a weighted average. Okay, did I give the formulas? Did I say what a convex combination is? They have to sum to 1, they have to be non-negative real numbers, and the P's are vectors. I'm done. B, draw pictures of, and now here's where I draw my pictures. So let's take, how about just P1? There we go. Now if I have P1 and P2, so K is equal to 2, there's my convex combination. If I have P1, P2, and P3, this is the set of all convex combinations. And if I have 4 points, then I get some sort of a quadrilateral or a tetrahedron. And so it's sort of fun to draw both, especially if you can try to do it. It's really hard to do this well, but there's maybe a third and finally a 4th point. And I'd get some sort of a tetrahedron. This is very difficult to draw. Okay, now it's a 3-dimensional object. Okay, did I draw pictures of all of them? Yes, I did. And this should say C, explain how to eliminate one of the parameters in convex hull of P1, P2. Okay, so I can do part C. The convex hull of P1, P2 is the set of all the C1, P1 plus C2, P2, such that C1 plus C2 equals 1, C1 is greater than or equal to 0, C2 is greater than or equal to 0, are real numbers, and P1, P2 are both vectors. Okay, then I'm going to write, since C1 plus C2 equals 1, then C2 can be replaced by 1 minus C1, so that we have C1 P1 plus, instead of C2, I replace it with 1 minus C1, an expression with only one parameter now. And here we have to make sure that C1 is between 0 and 1. Another way to say this is identical to writing like 0 is less than or equal to C1 is less than or equal to 1. Okay. So that's it. Okay, now I'm just going to think about where you might get tripped up. The difficult part to me of this is just remembering what are the C's and what are the P's. So the P's are vectors. We write PI is a vector in n-dimensional space. But we don't want to write PI is a vector. Like, this is a really long to say in n-dimensional space. And so instead of saying all these words, we have formulas that are easier to write and a computer would understand. You can literally type this into Julia, for example, and it'll give you a true or false. And so to me, that's the difficult thing about this problem, is just knowing what are the C's, what are the P's. When I'm doing the sum of the C's, this is adding up a bunch of real numbers. When I'm doing this sum here, this is adding up a bunch of vectors which have each been scaled by a real number first. So like this sum is totally different than this sum. Here we have a sum of vectors that have been scaled by different real numbers. Here we have a sum of scalars, or a sum of real numbers.